Solving, is that a solving problem? Has an equal. Factoring just says factor. That's it. When you are solving for x, you are solving for that x-intercept, you are solving for its 0. You are going to factor it down to its terms, what we call in parentheses, which generates a 0. Okay? What I'm looking at with these upper degree polynomials is that we're going to work with some short, quick ones. For example, 4x squared minus 24x. What is the first rule of factoring no matter what?
GCF.
GCF, okay? So if I want to factor, that, what's my GCF? 4x, good. Shh, ladies, what are you left with? X minus 6. Now, what if it had this? What would your two zeros be?
0 and 6.
0 and 6, good. Remember, when this comes out, you still set it equal to 0, which means x has to be 0, and this one obviously you get x equals 6. Now, you also know how to graph that via the tails. Which way are the tails pointing in this one? Up and up, good. They're both pointing up and up, but then could you plot it with up and up and your zeros?
Sure.
Absolutely. Okay. Little things like that. Are we going to, for $1 million, where's your axis of symmetry? Very good.
Where's the $1 million?
I left it at home. I can pay you in Smarties, I think.
Oh.
Why didn't teachers give us
You can pay me
Smarties?
in
They're
gum.
disgusting.
I don't know. We got Smarties. I don't know. I'm not a fan of Smarties.
They're like chalk. That's what you're eating.
Tasty, right?
There will be now some special patterns that we're going to have to pay attention to. We're going to start looking at a couple of the special patterns for cubes. Now, we've done this with squares, where you have what's called a difference of squares. When you had x squared minus 9, first term's a perfect square, last term's perfect square, subtraction in between. Well, when we deal with perfect cubes, is the first term a perfect cube? Yes.
Yeah.
Is the last term a perfect cube? Yeah. 27 is what cube?
3.
3. There are certain values that you guys are going to kind of be held accountable for knowing. 3 squared, 3 cubed, maybe sometimes 3 to the 4th.
Wait, did you just say 3 squared?
Yeah,
Oh,
you have to know that.
I was thinking that.
You know, same thing with 2s and things. So what happens here is that you get what's called a special pattern for a perfect cube. I can't use this on here.
That's not gonna work.
No, thanks. Appreciate it.
Good thing you didn't do the other way.
Yeah, I know. So here's what happens. You get this special pattern. You probably have not seen this before. When you have what's called a perfect cube, first term's perfect, last term is perfect.
Wait, so
I'm going to show you the pattern, then
Still
we'll use
right?
this to solve the factor of the x cubed plus 27. You're going to get, you're always going to get two setups. You're going to get a binomial against a trinomial. Okay? It is. It'll always be, when it's plus, it's going to be a plus b. And on the inside, you're going to get an a squared and a b squared. What happens now is a matter of working with the middle terms and the signs. That was good. Double check. Since it's a plus sign first, we go plus, minus, plus, but in the middle here we do a 2ab. And this will work every time.
Wait, so it's a squared
Minus 2ab plus b squared. So if I'm looking at our x cubed plus 27, this is, x is playing the role of a, so this is x cubed What was the cube root of 27? Bless you. What's the cube root of 27 again?
3.
So I'm going to write this as plus 3 cubed. That way you can see how it's going to work and as it filters itself into the pattern. That just means I get x plus 3, x squared, and the end will be a plus of 9, and the middle will be 2 times 3 times x. Oh, you know what? It's not a 2. I was thinking of the other one. I'm sorry. It's just ABs. It's Monday. I was off on Friday. I screwed something up. You didn't see that. It's just minus AB.
Here it is, memorize that.
So now it's just 3x. Because I'm looking like, wait a second, I can factor that further. That's not right. So you go plus, minus, plus. And it's AB times A squared minus AB plus B squared. Works every time. If it's a subtraction between the two, it changes just ever so slightly. Take a look here. I have the 16 u to the 5, or just write this as 16x. If I do that, what's the GCF?
16.
Does 16 go into 250?
No.
No, it does not. 4.
I don't know. What did you use to try to figure out? Okay.
No.
Type it in the divider.
It's 2.
Oh, wow.
What happens here is you get 2x squared as the GCF. You want to think 4 because you've got a 250 and all that, but you can see here if you go 4, 4 goes into 25 6 times with 1 left over. 4 doesn't go into 10, so you know that's not going to work. So you just take out the 2x squared. That leaves you 8x cubed minus 125. Is 125 a perfect cube? Yeah, it is, isn't it? What? Well, what's 25? Or what's 5 times 5? 5 times 5. There you go.
I need to learn my cubes.
Well, it's not so much having to learn them. It's 5 quarters is $1.25. So there's 3 sets of 5s. This one is 8 a perfect cube. Yeah. So this is your A cubed minus B cubed.
Interesting.
And this pattern goes, same deal, 2 to 3, minus, plus, plus.
You're just writing out so we can like remember this, or something different?
Oh, it's minus this one.
There's 2 different ones.
Okay.
You have the A cubed plus, you have the sum of the cubes, and then you have the difference of the cubes.
Oh.
So the after the AB, it's always gonna be plus B squared.
What's that?
It's always gonna be plus B squared.
Yeah. So you get those 2 special patterns. This is the part of this section, really, that is, I don't think you guys have ever done before. I don't think you guys have ever had a factor thing that had a perfect cube root to it. You've done some GCFs, you've done little things like that, but, so to finish this one out, bless you. To finish this one out, bring down the 2x squared, because it's still there. Stop. What's playing the role of A and what's playing the role of B?
8.
So what's the cube root of 8?
2.
2. So playing the role of A would be 2x. And then playing the role of B, 5. Now, when you put it into this part, you've got to be a little bit careful because you've got to square a. And a is 2x.
So
The quantity 2x squared is 4x squared. Yep. Then it's plus 10x and then plus 25. That's the weird one. That's the one that just takes the most practice getting used to because you haven't seen it before. The rest of it kind of falls into place now. Okay, the rest of it just kind of falls itself through. Yes, ma'am?
So whatever the GCF is, that's A?
Not necessarily. It's just have to be dumb luck.
Okay.
Okay? Not always. It's not always. Plus the A value here, I mean, if you're looking at the GCF is 2x squared, A was just 2x. They could be the same, but it's not as it happened. So let's try another one. And like here, so our little pattern. We just did that, blah, blah, blah. Let's do grouping.
Okay.
Let's factor via grouping. When you're factoring via grouping, there's kind of a dead giveaway that you're going to use grouping. You have 4 terms. That usually means you're going to group it. So I have x cubed minus 2x squared minus 9x plus 18. What I'm doing here is a very similar method to when we factored a regular trinomial, the quadratic, with the split middle term. You know how we do the multiply the tails to add to the middle? Where you had a leading term that wasn't 1, you'd have to get it to 4 terms. This is basically the exact same thing, but you're just starting with a higher degree polynomial. So all you have to do here is group them where they're sitting. Make sure they're in descending order and yank out the GCF. What's the GCF? X squared. Take out the x squared, I have x minus 2. When I get to the secondary part, I have to do the little plus minus there to remind myself to factor out the negative. So what's into the GCF?
Negative 9.
Negative 9, good. Take out the negative 9, and I have x minus 2. Are the things within the parentheses the same?
Yes.
Write it down. And what's left?
X squared minus.
Are you done, or can you go further?
You can go further.
What do you get?
X
Oh,
third, x cubed.
Oh, we're factoring, not foiling.
Minus 2x squared
X minus 3x.
minus 9x minus 8.
You wind up with the difference of squares with that x squared minus 9. So you can do plus 3 minus 3. X plus 3, x minus 3. You always want to factor, when it says factor, you factor it completely out. Okay? Factor it completely out. What would be your zeros in this case?
2, 3,
Good. Didn't matter which order you write out your terms?
No.
No, not at all. Doesn't matter at all, guys. Doesn't matter whatsoever. I know that we've done this. We just haven't done it with the cube. That's it. Sometimes you'll get something here that you're going to be able to factor further. Sometimes you won't. Okay? Now, if it's asking you to solve, you might be able to do something else where you can get an imaginary root, but we'll worry about that when that comes up. Okay? All right. 81x to the 4th minus 16. We're going to factor that. Now, at this point, hopefully some of the reminders of old ways of factoring start to pop in your head. For example, when you see 2 terms in subtraction, ask yourself, is the first term a perfect square?
Yeah.
Is the last term a perfect square?
Yeah.
Is that a subtraction symbol?
Yeah, it is.
So that means, right now, even though it's a 4th degree polynomial, it's a difference of squares. What would be the 2 terms you wind up with? 9x squared minus 4 and 9x squared plus 4.
Oh.
Can I go further?
Yes.
Which one?
Touche.
No.
No.
Just one of them. Which one of them?
Subtraction.
Is this a perfect square?
Shoot. Subtraction one because they're both perfect squares and they're minus.
Right. What I'm saying here is take a look. This is a perfect square, this is a perfect square, but this is not a subtraction symbol, but this one is.
Okay.
This one I can't go further to, but this one I can. Yes, ma'am?
So if
I
it
have it on my
was,
paper.
if the original equation was a plus, would you use the plus then? Or no?
Couldn't do anything then. You're done. That would be fully factored.
What?
You cannot factor 9x squared plus 4 any further. There is nothing, what times what is 4, you add together to get 0. Nothing. Okay? Now, if you had to find all of your zeros for this case, you could do that. For example, if I set that equal to 0, the first two are easy to find. Add 2, divide by 3. Subtract 2, divide by 3. So it's basically plus minus 2/3. On the other one, it's a little bit more difficult. If you set that equal to 0, and you want to solve for your zeros there, what do you do first?
Subtract 4.
Subtract 4, then divide by 9.
Yeah.
That's it.
Then you have to square root it.
Square root. What's the square root of negative 4/9?
I, 2/3.
No crap.
Maybe. Oh, 3 seconds.
Plus minus. Well, what's the square root of 4? What's the square root of 9?
3.
And what's the square root of negative 1?
I.
We said it.
That's it. So this one has, remember how we talked about the degrees, telling you how many total zeros you could have? This was a 4th degree polynomial, which means you can have up to 4 total zeros. In this case, we have 2 real and 2 imaginary. The real solutions would have been at plus minus 2/3. The imaginary were at plus minus 2/3 I. That's all. So depending upon the problem, it might tell you to get the 0, it might not. Miss
Are we
Lydia?
gonna have to graph the ones we got?
No. I'm graphing it right now.
How would we?
Think about it.
It's all in here.
It's all in here.
It's
It's a man.
Rainbow.
It's magic. It's a rainbow.
SpongeBob.
It's a rainbow. It's a rainbow of colors. Okay? I'm sorry that didn't clean up as nicely as I thought. This is 4x to the 6th minus 20x to the 4th plus 24x squared. Let's factor that.
4x squared.
First rule of factoring is always to do what?
GCF.
What's my GCF?
4x to the 7th.
Good. Take out the 4x squared, and I have x to the 4th minus 5x squared plus 6. Here comes a nice little trick. Inside the parentheses for that trinomial, notice that the first degree is 4, the second term has a degree of 2, and the last one is just your constant. Treat, when that happens, when they're going down in half like that, treat it just like you would a regular trinomial that was squared x and a constant. So what times what is positive 6 you add together to get negative 5? Negative 3, negative 2. So you wind up with, well, the 4x squared comes along for the ride, and you get x squared minus 3, and x squared minus 2. Because if you FOIL that out, you get x to the 4th minus 3x squared minus 2x squared plus 6, and it works. Anytime you have the degrees cut in half as you're going down, treat it the same way like you would before. Okay? Treat it the exact same way as you would before. What changes now?
X squared.
X.
What would your zeros be?
0.
0.
Plus or minus square.
Good. Plus or minus square root of 3. Plus or minus the square root of 2. Now careful here. How many zeros did I list?
3.
5. How many should I have?
6.
6 of them. Which one of these is duplicated?
Oh,
The 0 is duplicated because it's squared. So it's technically 0 and 0. Remember the term that we called that last week?
multiplicity.
Multiplicity, good. that has a multiplicity of 2 at 0 just means it's there twice. So if you were to graph this,
Let me actually have the graphs.
the original one, where are your tails going?
Up.
Up and up, right? We're we're positive and even, so we're up and up. I know that I have root 3 is bigger than root 2.
Yes.
So it means its tails are up, so it's got to go down through here, change up, touches here, goes back, down, and up. It has to look like that.
Can't be
It has the
original.
leaves.
It has to.
Oh.
Just because the way the tails are, the multiplicity of 0 by it being 0 twice, that means it just touches the axis. Am I close, Vito? I know you're putting it in there right now.
Yeah, you're close. I looked at it.
You had that doubting look on your face. Oh, there it is. I forget my cube stuff, but I can still graph a polynomial. Okay.
Oh, I don't think I do that.
As we've been going through, I've been just throwing in the equals 0 towards the end of after getting your factors and stuff, just to kind of continue to show you guys what your next step would be. In this case, it's telling you right away to solve, and you see an equal sign. So,
Yeah. Subtract.
I was just, yeah, I mean,
yeah, all right, take a minute and do it. Get your zeros.
All right.
you were.
Wait, yeah.
And do a split.
Oh, but I just did.
Shoot.
Yeah. I forgot to divide the two. Oh. Yes. Yeah.
When you are solving equations, do you have to show all your steps down to the last set of terms?
Yes.
No. You don't have to. You don't have to write this out as 2x, x plus 2, x minus 2, x. Well, then that'd be x squared minus 3 and be done. You don't have to write that out in terms of pure factor. If it says factor, yes, you have to factor it all the way out. If it says find the zeros, once you get to where you have the difference of squares and you want to go ahead and just solve it, it's fine. That's exactly fine by me. Okay. One of the tricks when you're working with grouping, the first parenthesis you get, once you get that GCF out, the second one should look exactly like it. Otherwise, you're doing it wrong.
I did it wrong.
Plus minus 2 or negative 7/3.
I forgot
Oh,
4
I keep
came out.
forgetting the plus or minus.
I forgot 4 came out.
Okay. Wait, waiting.
3x plus 7.
Thanks.
Sorry. No worries. It's a shame the weather wasn't nice out Saturday like it was yesterday.
Yeah.
Poor children.
It was bad.
This is easy. I'm trying to think about a more difficult one. No, I don't want to do those. I want to do different. So here's what I want you guys to do. On 6-4, it's page something or another.
What page is sorry?
I'm going to go look.
But what are the others?
349.
What? No, I wouldn't. Should I tell you? Yeah, you should tell me.
Wouldn't that be going by every other odd third? So wouldn't that be going in nines? Okay,
Yeah.
go every third on those.
I don't understand.
1, 2, 3, 4.
Wait, should I take a circle? It's like a, yeah, it's like a no. How does that
I
possible?
should fly through. Hey, real fast though, make sure you put down the cube one. Put that on your worksheet. Put that on your homework sheet so you have it in front of you, because that'll pop up every once in a while. Yes, sir.
When I was gone on Thursday.
Yeah.
I turned in the homework that was due on Thursday, to the sub on Friday,
Oh,
and
okay.
I was wondering if you got it.
I don't know.
You just look too confident.
Because I didn't want it.
Was it easy? Yeah, it was easy.
Mental note: don't give stuff to subs.
Okay.
Oh, okay. You feel me? Yeah. So that sounds like it's a yes and a
It was
no.
almost a
So
tail.
it's like, I don't.
Okay. I'll dig around and see if I see something in here. Yeah, it's usually a good idea not to do that.
Yeah, don't give anything to Mr. Foyle.
Hey, when you get down to some of the ones at the very end when they have the zeros, it wouldn't be a bad idea to practice what it looks like in terms of a rough graph, because I might have you do that on a quiz. Which means I might not let you have a smart calculator on a quiz.
But will he have like a down?
Yeah.